always love to hear from you. Send us your views, comments, and videos with your name and town to the One Africa TV's WhatsApp on 081 200 6659 or send an SMS to 555. It just gets better.
Bring the family together with great specials like Spa Wolf Dog Chunks for only $104.99 and Huggies Dry Comfort Nappies Jumbo Pack for just $155.99. We're here for you.
Let us look at another example. What is the length of x in the following diagram? So let's have a look at this. As you can see, we have a rectangle with a few lines drawn in it. We're going to start by constructing a line. So I want to put a line going up here. And if we draw this line perpendicular, you can see we get one triangle formed here. And we already have the triangle formed here. So we need to find the length of x. But x is the same as the length from here to here. What we can do is we can find the length from here to here using the first triangle. We can find the length from here to here of the second triangle. So let's call this Z and this Y. We get the following triangles. We get Y, we get a right angle. We know this is 5 meters, and we know this is 4 meters. We also get the triangle Z. We have a 90 degree. We know this is 4.5 meters. And because this side here is the same length as this side, it is equal to 4 meters. So this is the hypotenuse of triangle 1, and this is the hypotenuse of triangle 2. So let's say triangle 1. So we know Pythagoras states that the hypotenuse squared is equal to the sum of the other two sides squared. So 5 squared is going to equal to y squared plus 4 squared. So 25 equals to y squared plus 16. Therefore 9 is equal to y squared. And therefore y equals to 3. So this length here is equal to 3 meters. Now using triangle 2, we get that 4.5 squared is equal to z squared plus 4 squared. So we get 20.25 is equal to z squared plus 16. So we get 4.25 is equal to z squared. Therefore, z is equal to 2.062. So, we said that x is equal to y plus z. So we have that x is equal to 3 plus 2.062. And therefore, x is equal to 5.062 meters. Let us recap everything we've just learned. So, the hypotenuse is the longest side of a right angle triangle. It is the side opposite the 90 degrees. So if here's your 90 degrees, there's your hypotenuse. So, the theorem of Pythagoras stated in words is, in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So mathematically, this is the hypotenuse squared is equal to side 1 squared plus side 2 squared. Or, if you want to draw the triangle, so you have a right angle, you have your hypotenuse, you have side 1 and side 2, then you get this formula. This is the most common way to represent it, so it's nice and convenient. Just make sure C is your hypotenuse, and A, make sure it's the side that isn't the hypotenuse, and B is the other side that isn't the hypotenuse. Another thing you can use Pythagoras' theorem for is if you wish to see if this is a right angle, you use the sides of your triangle and you check if they obey this formula. If they do, then you have a right angle triangle. You must always let C equal to your longest side, and A and B are the other sides. So once you do that, check this. If it's true, then you have a 90 degrees.
Let's talk about your good friend Bodmas. Remember, B is for brackets, O is for powers, also known as indices. D is for division, and he comes before. M for multiplication, if you can spell it. A is for addition, and our last one is S for subtraction. Now this rules, this order, this way of doing things, this is completely non-negotiable. If you have 3 plus 1 squared minus 4, 2 times 3, what should we say, plus 8 divided by 2. You have to do this in order. Okay, so first comes our brackets. That means we must sort out what's inside the brackets. So in this one, 3 plus 1 squared. Well, 1 squared is 1 times 1. Remember, we must do your power before your addition. So it's 3 plus 1 in that bracket. Minus 4. 2 times 3 is 6. Plus 8 divided by 2. Yes, I'm going slowly. I want you to be absolutely sure you do everything in the right order. So, 2. 3 plus 1 is 4. Minus 4 times 6. Plus 8 divided by 2. So, who comes next? Division. So technically, we've still got 2 times 4 minus 4 times 6, but now plus 8 divided by 2 is 4. Now we finally got to multiplication. 2 times 4 is 8, minus 4 times 6 is 24, plus 4. Now Bodmas tells us we do addition before subtraction. So 8 minus 24 plus 4 is 28. So 8 minus 28, well, we've got a plus 8 and a minus 28. We've got unlike signs. So we can do 28 minus 8 gives us 20, and the sign of the bigger number is negative. So our final answer is minus 20. But again, I cannot reiterate enough how important this little rule of doing things is. If you do not follow Bodmas as you're working through algebra, as you're working through equations, you're going to get things wrong. So always make sure that you're doing things in the correct order of operations. I cannot stress enough how important Bodmas is. Things in life happen in order. You get rose buds before you get rose flowers. And it's exactly the same in maths. Things must happen in order. B is for brackets. O is the odd one, powers, otherwise known as indices. D for division. M for multiplication. A for addition. And S for subtraction. And this is the order that you must always do things in. When you've got multiple operations, you go through them and you think, this is the order I do them in. Otherwise, you're going to get the wrong answer, and it's just silly because you know how to do this. So, if we look at this example here, and we work through it like we're told to. So, brackets. So first we must sort out what's going on in the brackets. Well, we have 3 minus 1 is 2 squared. Now we haven't dealt with anybody else yet, so it all still stays the same. Our next one is powers. Well, we do have one of those here. We have 2 squared. Remember, 2 squared means 2 times 2. So we have 4. And we haven't dealt with anybody else yet. Next we can do our division, then our multiplication. If we look down here, we have a division, but no multiplication. So we can do 4 plus 10 divided by 2 is 5, minus 3 we haven't dealt with. Addition before subtraction, so 9 minus 3 gives us 6. So yes, it might seem a little bit silly to work through a whole lot of these, but the idea is to build habits. If you build the habits now, it makes your life a whole lot easier when you move forward into more complicated maths and more complex questions. This is something that you need to make second nature. Bodmas, brackets, then powers, then division, then multiplication, lastly addition and subtraction, always in that order. Let's look at a ratio question. This question says, on a trip to Kruger National Park, I took 470 photos. 30 photos were of sunset or sunrise. What is the ratio of sunset, sunrise photos to other photos? So we're looking at a ratio. We want to know sunset, sunrise to other photos. So they tell us we have 30 that are sunset or sunrise photos. Other photos, well, we know that there's 470 total. So if we take out the sunset and sunrise ones, we're left with 440. So our ratio is therefore, we have 30 sunset sunrise to 440 other photos. But remember, you must always reduce to it in its simplest form. So quite obviously here we can get rid of 10 from both sides. 3 to 44. 3 doesn't go into 44, so we can't take it all the way down to 1. And there's nothing else that's common to both, so that's our final answer. The ratio is 3 to 44. When you're giving a ratio answer, there's 3 ways. The way we've just used, with a colon in the middle. In English, you would write it out 3 to 44. You can also give it as 3 to 44 as a fraction. The first method is the one that's preferred. We're not in English, so we don't want to be writing out. And to give it in this fraction format can make it a little bit dodgy when we're working with things later. So if you're asked for ratio questions, always, unless told otherwise, give your answer in the colon format. So, predator counts in the Kruger National Park have estimated the following numbers. We've got 5,340 spotted hyenas, 1,720 lions, we've got 1,000 leopards, we've got 120 wild dogs, including this one, and we have 120 cheetah. Now if I asked you the question, if you see 10 predators on your holiday, how many leopards do you expect to see? We need to turn this into a fraction. So, our ratio here would be 5,340 to 1,720 to 1,000 to 120 to 120. Okay, so if we want to pull a fraction out from a ratio, we have to take the number that we're interested in. We're going to talk about leopards today, so it would be our 1,000, because leopards there are 1,000. And we need to take our interesting number and we have to put it over the sum of all of them. So 5,340 plus 1,720 plus 1,000 plus 120 plus 120, this gives us 8,300. So we can simplify that. That's the same as 10 out of 83. So now we have the fraction of our total predators, which are leopards. So we can look at our question. If you see 10 predators on your holiday, first of all, you're very lucky, but how many leopards do you expect to see? So remember, our fraction for our leopards was 10 out of 83. And we got that by saying our number of interest for the leopards was 1,000, divided by all the predators, 8,300. So, we then want to say, how many leopards do we expect to see out of 10 predators? So, we expect to see our 10 predators times our fraction that we would expect to be leopards. This makes 1.2 leopards, which is highly unlikely. I don't think you're going to see a leopard leg walking down the road. So, you would expect to see 1 leopard. So when you've got a ratio, and you have to pull a fraction out of your ratio, you take your interesting number, put it on the top, and then you add all the numbers from the ratio, put it on the bottom. Simplify as needed, and then you can use that fraction in further calculations.
In this video, I'm going to be looking at a section which is sometimes referred to as line graphs, but I'm going to be referring to them as graphs of changes with time. So when any data is collected over a period of time and we plot a line graph, we can call this a line graph, and it's specifically a change with time line graph. So the time is always plotted on the horizontal x-axis. So we've got time over here. We can refer to time as the independent variable because what we're measuring will depend on the time at which we're measuring it. And the variable that is measured as it changes is plotted on the y value. So this is the other variable. And it could be anything. The important thing here is the other variable would change with time, and the way that we would join these different points that we've been given is using short dot-to-dot method type lines. Oh, I think I should have gone up down. All right. In this example, we're going to draw a line graph for the number of cars parked in a car park recorded every hour on a particular day of the week. So we're going to start by filling in our times. So we're going to put 9 there, 2 blocks later 10, 11, 12, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, and 6 o'clock. Okay, so please note each of those is every second line. I could have done every line, but I wouldn't then have used the best amount of my graph space, and that sometimes helps for you to have extra information that you can then measure on the half hours as well. All right, the number of cars ranges all the way, oh my goodness, from 3 to 20. So we've got to make sure that our values go up here. So if I did them, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. So I think I'm going to go up in 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and we hit our 20. Cool. Label your axes. Over here we have number of cars. That's on our y-axis. On our x-axis we have the time. You could obviously write 0.00, but I'm just doing the points for now. So at 9 o'clock there are 16 cars. We mark that off. At 10 o'clock there are 10 cars. At 11 o'clock there are 4 cars. At 12 o'clock there are 5 cars. So we're going to have to go between the 4 and the 5. At 1 o'clock there are 3 cars. So we're going to go between the 2 and the 3. At 2 o'clock there are 6 cars. At 3 o'clock there are 8 cars. At 4 o'clock there are 14 cars. At 5 o'clock, that's our peak, there are 15 cars. And at 6 o'clock there are 14 cars. Now, this is a rather unusual distribution for a car park. What you may actually find it's a car park outside a gym. And your peak time for gym is after work and in the morning, early in the morning. So that could be a realistic point here. Now, I don't have a ruler here, so I'm doing these as straight as I can. But you're literally going to be joining every one of the points, dot-to-dot style, with a ruler. I don't have a ruler. You find a ruler. We're joining them all together so that we can see the general trend that is formed. What you then need to do is go and answer the questions. Now, I needed the questions to be in the same place as the graph, so I put them over here. You are asked, from the graph, estimate the number of cars parked in the car park at 5:30. So here is 5:30. So if I go up and I measure off the graph, I can see that it is somewhere between 16 and 18. So I would probably estimate that there are 17 cars. I would not yet say that there are 18 cars because 18 would require me to be up here. So I think 17 is a good estimate. You are then asked to estimate the amount of time during the day when there were more than 12 cars in the park. So that means it's that amount of time there, okay, more than 12, remember there's our 12, as well as that amount of time there. So we're going to have to estimate how many hours these are. So I'm going to say there's an hour, there's an hour. To be entirely honest, I think that this little gap fits in here to make another perfect hour there. So my answer would be, for 3 hours of the day, we have got more than 12 cars in the car park. Please practice these. Remember to use a ruler. Remember also whenever plotting a graph to use a pencil. Makes it so much easier to erase if you make a mess up, or if you start labeling your axes and then discover everything doesn't fit.
In this lesson, we are going to look at exchange rates, expressing money in terms of different currencies, and concepts that are associated with profit and loss. Currency is the money that is used in a country. If we look at South Africa, the currency is rand and the symbol is an R. If we look at a country like Japan, the currency is called yen and it has the following symbol. Greece uses the euro and it has the euro symbol. England uses the pound, which has the pound symbol obviously, and the United States of America uses the dollar, which has the following symbol. Now, we may often ask ourselves, how many rands can we buy with $1 US? Or, if a shirt costs 10 pounds, how many dollars is the shirt? We can answer these questions by using simple ideas from ratio. John wants to purchase a piece of American art. The piece is valued at $124,800 US. If John lives in South Africa, what will the value of the art piece be in South African currency? The exchange rate is as follows. $1 US buys 8 rand 19 cents. To answer this question, we simply set up a ratio. We know that $1 buys 8 rands and 19 cents. Therefore, we have the ratio 1:8.19. Now, to get from $1 to $124,800, we multiply the left-hand side of that ratio by 124,800. And so, from our concepts learned with ratio and proportion, what we do to one side of the ratio, we do to the other. So we take our 8.19 and we multiply it also by 124,800. This then just gives us the rand equivalent of the dollar amount for the art piece. Therefore, the art piece is equal to 1,022,112 rand. Example 2. Example 2 says that you're given the following exchange rates. You are told that 0.58 euros will buy you $0.49 and $2.15 will buy you 145 yen. If a man is going on a trip and let's say he has 198,624 yen, what would he need in euros if he is going to Italy? This is the process that we would need to follow. We need to take our yen amount and convert it to dollars. We then have to take our dollar amount and convert it to euros because of the way that the exchange rates have been expressed to us. So, let's look at the yen to dollar conversion. Firstly, we know that $2.15 buys 145 yen. That means 2.15 is to 145. Now, we need to get our yen amount, which is 145, to 198,624. So we multiply the right-hand side of that ratio by 198,624 all over 145. Therefore, we do the same to the left-hand side of the ratio. And so, 198,624 yen will buy us $2,945.114483. We now need to employ the following step, taking the dollar amount and converting it to euros. So, we have been told that 0.58 euros purchases $0.49. So we set up the ratio 0.58 is to 0.49. Now, we need to take our 0.49 and get it to